Good morning. Today's class, what we are going to see is, as I have written here, moments. What are moments? What is the significance of moment? How do you apply principles of moments? And what's the difference? Like, how do you approach these kind of questions? Yeah? Some tips and tricks for you to remember so that you can apply it effectively and get the answers correctly. All right, shall we start? Okay. Now, what is moment? By definition, moment is the turning effect of force. Okay, the key term here is turning. Okay. Forces may have different effects on different objects. It may increase the speed, decrease the speed, make it come to a stop, or start it moving, so and so. But then, if the force exerted creates a turning effect, then that effect is called moment. All right. Now let's see a simple example. Imagine this board to be a door. Okay. Now the handle is on the other side where I place the duster. For example, the handle is here, and if you open it, of course you are applying a force. You need a force to open it. You pull the handle and it turns through an angle, right? Now here, this part of the door will be fixed point. So when I am pulling it, you just make the door turn. This effect is termed as moment. Now, what's the difference if this wasn't fixed? If I move, probably I may even shift the position of the board, right? That means I'm just moving it, correct? Now, those are not termed as moments. Only when the force applied creates just a turning effect without displacing the object. So you need to have, in that particular situation, a fixed point. Got it? There should be a fixed point, and then you're trying to shift or turn the object. Those situations will be treated in terms of moment. Now, what is the definition I told you earlier? Turning effect of force is moment. Now, how do you calculate by how much it will turn and what would be the effect and so on? We have a formula. The formula states moment equals F into D. This is in symbol form I have written. The formula states F into D will be equal to moment. Now, what is the expansion of M? Moment. Expansion of F is force. Now, this D you have to be careful. Okay. Most of the times students just leave it as distance. No, it is distance perpendicular to the pivot. I repeat, distance perpendicular to the pivot. This symbol stands for perpendicular to the pivot. This again is the key term. Okay. So if you asked to write the definition, you may go ahead with the phrase turning effect of force, or you may add one more detail to it. It can be calculated by using the formula force multiplied by the distance that is perpendicular to the pivot. Now, what does it mean and how do we find out which is the distance from the pivot? We'll see in a bit. When I gave you the example of having this as the handle here, right? Now, say if I move the handle to the middle point of the door. Imagine this to be the door. Usually the handle is on the right extreme. Now, say for example, if the handle is shifted to the middle and you are trying to open the door, would it be easy for you to turn the door, or will it be difficult than that? Of course, it's going to be difficult to move or turn the door if I shift the handle towards the left. I hope you all got it. The handle's position determines the turning effect, or in other words, moment. Okay. So when I change this handle, which quantity is changing? The distance from the pivot I am keeping on changing, correct? So as I change the distance from the pivot, the turning effect also keeps changing. Now, another point to note. Now, say if it was here at the same position, if I shift the position above, okay, the handle is moved vertically up, if I move the handle vertically up, will it have any difference in the turning effect? It will not. You can still be able to open the door with the same amount of force. Okay. The same goes to if you move it down. So note this point. If I move this handle, or the point where I'm applying the force, if I move it vertically, it's not going to have any effect on the turning effect. But if I move it closer to the pivot horizontally, it's going to change the turning effect. Getting that point? Okay. Hence, that's why I said when you're just writing distance, it could be any random distance, but in moment, the formula, it denotes if you change the perpendicular distance from the pivot. See, this is your pivot here, right? This is the fixed point. That's your pivot. Now, this distance is what you are varying, right? So, which is perpendicular to the pivot. Got the point? So, if you vary the perpendicular distance from the pivot, if you vary, the moment is also going to change. Okay, you can try with some what should I say, values, and check how it varies. When you keep it in the middle, it becomes half. When you keep it, increase, double the distance, the moment increases, and so on, right? Now, that's about just moment we have discussed. Okay, so keep it in mind, because sometimes MCQs, they give you like different positions and they ask you which one is easier to open and close, or which is the point that doesn't have any effect on the turning effective force. Please keep all these points in mind. Now, moving on to the next point, principle of moments. What do we mean by principle of moments? I'll give you the statement, then I'll explain it what it means. The total anti-clockwise moments, I repeat, the total anti-clockwise moments is equal to the total clockwise moments. That's point number one, which generally if you write, you score for principle of moments. But there is one more point which also is applicable. The total upward force will be equal to the total downward force. These two other points, I repeat. First one, total clockwise moments will be equal to total anti-clockwise moments. Second point, total upward force will be equal to total downward force. Now, where do we apply? We'll see it in a simple example first, then we'll go to some challenging questions. Say if you have a beam, you can relate it to the seesaw. Okay. So this is the platform and you have the fixed point which is in the middle. So this is your pivot. Okay. Now, if you want to make it balanced, if this is evenly distributed, means if you have the beam to be having uniform cross section, then it will balance perfectly at the midpoint, right? It will balance. Now, say for example, I apply a force here by placing an object. Say an object is placed here. Okay. Now it's placed freely. So what's the force that it exerts? What's the name of the force? It will be acting vertically down due to gravity, which we call it as the weight. So here, weight is the force that will pull the beam down. Now, what will happen to the beam? The beam will tilt, correct? It will topple and you will have this tip down. Now, if I want to bring it to a balance again, what do I need to do? If I want to maintain the beam's position as is, then I need to place another object here, right? Another object here. Say if I take equal mass as that of the other object, if I place it at the same distance, you can see that both will be again balanced. Am I right? So equal weight or equal force will be pulling it down and you will notice that it will be balanced. It's a very simple, straightforward situation. What if I have a lighter object? Okay, again you can relate to the seesaw, a heavier person and a person who has got weight less than that. Is it possible for them to balance? Some of you might think no, but it is possible. But then we have to make a little bit of changes here, like say if this is the heavier person or the heavier object, if you move it closer to the pivot, okay, the heavier object, if you move it closer to the pivot, you will notice you can still be able to balance. Now in such situations, you can apply principle of moments, and if any quantity is unknown, be it the distance or one of the forces, the weight that if you would want to know, you may apply this concept and figure it out. Now what's the method? Say for example, if I label this as W1, this as W2, and the distance from the pivot. This again you have to be careful. Here, as I told you earlier, this is a very straightforward situation where you have the pivot in the middle. We'll see in another video a little bit complicated situations where the pivot is not in the middle and how to approach those problems, because that's where students make most of the mistakes. Now here the pivot is in the middle, so you take the distance from the pivot. Okay, since the force is acting here, you note this is the distance which is again perpendicular to the force, right? See, this is the distance that you need to measure. So you can see the distance and the force are perpendicular to each other. Now say if this is D1, and what would the distance that you need to measure for this particular weight or the force? It's D2. Okay, now which one is clockwise and which one is anti-clockwise, we'll see. Now the force that is pulling here, it will make the system move this side, correct? If this is pulling it down, the beam has a tendency to move that way. So in a clock, you have this to be the clockwise moment, and if it goes against the moment of the clock, then it's anti-clockwise moment. So this force is creating a clockwise moment, and this force is creating, or it's pulling it in the other way down, so it is the anti-clockwise moment. So applying principle of moments, I can write the equation as the clockwise moment will be force multiplied by the distance will be equal to anti-clockwise moment, which is force multiplied by again the displacement. So if any of these, if W1 is known, W2 is known, D1 is known, if you want to find D2, you can plug in the values and calculate it. That goes for any of the missing quantity, the approach is the same. Okay, now say if there is one more force, how will the formula change? Little say for example, instead of one weight here or one object there, you have one more which is at a different distance. Okay. Now if you take that weight as W3, how will the formula change? First you analyze the situation and see how many forces are acting and collect all their moments, not the forces. Okay. Another common mistake, if there's a question, if they ask how is the beam balanced, there is a tendency to make it as a statement, the forces are balanced. No, see the forces, or sometimes they say the forces are equal. See here, are these forces equal? They are all of different masses. The forces also, the weights also will be different. It's not the weight, the what should I say, the similarity in weight that balances, but it is the moment that balances. Okay, so the total clockwise moment will be equal to the total anti-clockwise moment in a balanced system. Now since there are two forces acting here, you have to add their moments, not just their forces. Keep that point in mind, add their moments. Now as we saw earlier, the moment due to W1 will be W1 into D1. And what will W3 be? The moment due to W3 will be W3 multiplied by the distance from the pivot to that particular object. Okay. So how will the formula be? W1 D1 plus W3 D3, the two moments which are acting clockwise, will be equal to W2 D2, which is your anti-clockwise moment. Okay, this is how you have to approach the problem. So we have seen two situations for a beam which has got the pivot exactly in the middle. Okay, in the next video we'll see if the pivot is not in the middle, if it is shifted to the left or the right, how to approach the question. That's totally different. You have to be very careful. As I said, that's where most of the students get confused or miss out some details. So see you in the next video. Bye.